Hello, everybody. I will start my today another live coding session. So today I solve this question: find first and last position of element in sorted array. So given an array of integers num sorted in non-decreasing order, find the starting and ending position of a given target value. If target is not found in the array, return -1, -1. You must write an algorithm with overlog and runtime complexity. Okay. So let me clarify my understanding first. So as the interface, I'm giving an integer array nums, and I will return the tuple of integer and integer. So this integer and integer represent indexes. Oh, and also I'm giving the target value. So target value can be number. Maybe this can be integer or maybe not. Yeah. Okay. So let me think. I think as the edge case, if I'm given something like an empty array, yeah, whatever the target is, I should return -1, -1. Yeah, good. So far, it's okay. So, for example, if I'm given something like this, and if the target is 3, then I should return 0, 1, because number 3 is here to here. I should return index 2 to 4. Yep, pretty simple. Okay, but if there isn't the number, so when it looks like this, like 2.5, I don't know, maybe I can make it. In this case, I should return -1, -1. Yeah. Of course, if there is only one number, like if the target is 4 in the first example, I should return 0, 1, 2, 3, 4, 5, 5. Okay, so I think there are these 3 cases I have to take care. Actually, yeah. And also the edge case I've given first. Yeah. Okay. So far, it's okay for me. So let me think of the brute force approach. As a brute force approach, what I can do is doing the linear scan. So given nums array is sorted in non-decreasing order, so once I find the target, I start the counter. I mean, it should be the first index of the target, and then I keep traversing. And every time I move the index pointer, I update the end index as long as the pointer is pointing to the target value. But the pointer is pointing to the number which is larger than target. That's the end. So I don't update the end index. So now I got start index and end index, so I return it. Yeah. So it takes O of n time, assuming that there are n element in the array. Yeah. Okay. Good. But obviously I can optimize this using the binary search. So I get this example. So in this case, I do the binary search first. Sorry, binary search twice. The first one is I do the binary search to find as the number which is larger than 3. So in the binary search 1, I did the binary search in here. So num is larger than 3. So when I think of this question, this number should be false, false, true, true, and true, true, true. So here, I find the first true index, which is in this case 3. No, 2. Then I do the binary search number 2. This time, no, larger or equal to. So this is something I take care, and I find the index of the first true. Next, what I'd like to think is the last index, which means this. Yeah. So when I think of this question, this one is, yes, smaller. This one is smaller, smaller or equal, smaller or equal, equal, but none and none. So I can say last true index is 0, 1, 2, 3, 4, 4. Yeah. So once I got this number, I return to 4. But I have to take care that in the case of this 1, 2, 3, 3, 3, 6, 7, in this case, this becomes invalid because in the first question, first true index is this one. First true, last. So 0, 1, 2, 3, 4, 5. For Q2, last true index is 0, 1, 2, 3, 4. So I actually can't find any, index in between. Yeah, this and this. Again, I'm saying, if there is any, range which means this and this, I have to return -1. I can say if first true index, last true index in this range, in this, relationship, I return first true, last true index. Otherwise, I return -1, -1. Yeah. So that's something I would do. Again, I would say, I split the, so instead of thinking of only, exact target 3, I checked the range, um, in which the number is larger than or equal to 3. And the same for, this one. Then I take a look at the, common range. Okay, that being said, for time complexity, this should take log n time because, so I did the binary search twice, and in the binary search, it takes log n time, assuming that there are n element in the given array. For space complexity, it should be constant. I didn't use any, non-constant data structure. Okay, that being said, let me get started with the implementation. So firstly, I want first greater than or equal to index. Then I get first less than or equal index. Then in the end, if this is true, I return this and this. Otherwise, as I said, I return -1, -1. Yeah. Now my task is to implement these two helper methods. Okay, so first greater than index. So here I will dig a real deep, explain a little bit about the binary search, um, algorithm. Let's say target is 4. In this case, I start with low and high. So in any range, in any index of index 0 to this, it is possible that this is true. So while there is a range, there is something IDX, medium number. Then I take a middle number, and I can say if this middle number is smaller than the target, because I'm looking for greater or equal, low is middle plus 1, because middle number is too small. So at least it has to be larger than low. And otherwise, num's middle is equal to target or larger. This means that at least this middle should be included. Maybe this middle index can be the first greater than or equal index, but it can be before that. For example, this case, if middle is 4 here, second 4, yes, this 4 is greater than or equal, but previous 4 is also greater than or equal. So I can say high is equal to middle. Yeah. So in this way, I narrow down the range of low to high. And in the end, so here I can say low is equal to high. So when low is equal to high, so what I can say is this can be the greater than or equal index or not. So I still have to check it. But here I can include equal in that way. Let me check that case. When low is equal to high, like this, maybe here. In this case, middle is equal to low is equal to high. And because this is smaller than target, low becomes middle plus 1. Yeah. Otherwise, high is middle. So it doesn't change. Maybe in this case. I'm a bit, confused. So in this way, I'm looking for the first greater than index. Here, I can say low is equal to high. So Okay, so let's say if I take equal here, so if low is equal to high, what happens is if this is smaller, that low index, high index, which is equal to middle index, is smaller than target, I move the low index plus 1 here. Otherwise, if it is something like here, I is equal to middle, so nothing changes. So what I can say is, I check this, and in the end, low index should be the first greatest index, as I saw here. Low is a middle plus 1. Yeah. Okay. Good. Let me test it in the dry run, in this case. In that case. Oh, one more thing I have to take care is, because I do low is middle plus 1, in the case low is 2 and high is 3, middle becomes 2, and middle plus 1 is 3. Yes. Okay, so my concern was it doesn't cause the infinite loop when high is low plus 1, but it doesn't. It's okay. So here I implement the first less than or equal index. I go quickly here. This time, first less than or equal index. Wait, am I doing correct? First less than. No, this should be last. Last less than or equal index. So, wait a minute. So last less than or equal index here. So let's say I have this one, and if middle is here, if num's middle is smaller than the target, yes, it's fine. Or if it is equal, yes, it's fine. This middle is last less than or equal number, but it can be greater than that. So low is middle. But if this middle number is too big, the last array index should be before that. So it should be like this. And when I do this, I have to take care that when I take this, I have to do plus 1 here. Otherwise, when low is 2 and high is 3, for example, middle becomes 2 with this one, so which means that low can be infinitely 2. In that case, it becomes a for loop. But when I add this plus 1, when low is 2, high is 3, middle becomes 3, the low is up incremented here, or high is decremented here. So even if I is equal to rho plus 1, the range narrowed down. Okay. So now again, I will check the final case. Let's say low and high is equal in the last, loop. And here, what happens is, if it is smaller than target, I do low is equal to middle. So I don't move from here. But here, if it is larger than the target, maybe here. So what happens is, I is middle minus 1, I becomes here. So yes, so this is exactly the last greatest than or equal index. So I have to take a look at the high index. Okay, this is it. Oh, it's been 20 minutes. Good. So let me dry run my code. So yeah, let me, go really quickly. In this case, I should return. Oh, maybe I should start from the edge case here. So if the given array is empty, what happens is first greater than or index begins with low 0, high -1. So I return 0. And actually, this doesn't make sense. Here, this low and high, high index ranks nums -1 is -1, which doesn't make sense. So let me treat it as the edge case. So in this way, I don't have to take care of that anymore. So with this test case passed. Okay. So test number 2. Let's think of this case. Target is 2. In this case, I should return 1, 2. So in this case, first greater than index should be, it begins with low 0, high 2. So first is 0, 2, and middle becomes 1. And now nums1 is 2, which is not smaller than target 2. So I go to line 95, and high is middle. High becomes 1. Yeah. Then I come back to line 90, and still higher than low. So I go to line 91, and I get 0 plus 1 divided by 2 is 0. Yeah. So nums middle, which is 1, is smaller than target. Yes, the low is middle plus 1. So now low is 1. So they are equal index 1, which is 2. Yep. So now I come back to here, and middle is 1. And nums middle, which is 2, is not smaller than target. So high is equal to middle, which is 1. So I return low, which is 1. Okay, good. So this one is 1. Here, let me, assume that this method is correct. And I get index 2. So in this case, 1, 2, I compare them, and 2 is larger than 1. Yes, so I return 1, 2. Okay, I did pass this case. Yeah. To save my time, I didn't cover completely last laters or equal index. But let me come back if something goes wrong here. Yep. So I will submit. Oh. Maybe infinite loop. Okay. So from my experience, as I said, I think, infinite loop occurs here if time limit exceeded is caused inside of the while loop in binary search. So let me check it again. I'm looking for first greatest or equal. If this is 0, 1, it becomes 0. Yeah. Oh, wait. So if there's the same, what happens? Like 2, 2, middle is 2. Oh, I see. So if there's the same, high is never changes. So for example, low is 2, high is 2, then middle is 2. So if I go to line 94, high is equal to middle, which is 2, infinite loop. So what I can do is, instead of this, I do this here, and I do this check one more time here. If so, I expect low is equal to high here, and num's row, which is equal to num's high, is smaller than target. I return low plus 1. Otherwise, I return low. But the problem here is, do I have low plus 1? I see. So the problem here is, first greater than index can be infinite. Maybe. No. It can be 0. Hmm. Okay. So if num's row is smaller than target, yeah, it's true. If first, it is possible that I can't find any number which is greater than or equal to target. In the case, all the numbers are quite small. So in that case, I will return infinite. Yeah, I will return row plus 1, which can be out of the index, but it's okay because in that case, this first first G index becomes n, ranks as a nums. So last racism or equal index never exceeded or equal, so I return negative and negative. It's okay. The similar thing here. If this is smaller than or equal to target, I just return high. But if larger than target, I return high minus 1. Yep. In that way, this can return negative 1, but it's fine because in that case, this should be smaller. Right? This should be always smaller than first greater than or equal index. I return negative 1, negative 1 as expected. Okay, let me try again. Oh, sorry, and I removed this. Okay, good, accepted. So let me quickly wrap up. So today I solved the question. First, find the first and last position of element in sorted array. So in this question, I'm giving an array of integers, um, you know, in strictly decreasing, non-decreasing, non-strictly increasing array, and I return the first index and end index of the target in the given array. So for this question, I used the binary search twice, and firstly, I did the I tried to find the first greatest or than or equal index And then in the second binary search, I try to find last less than or equal index compared with target. Yeah. So, and I was like compared if first G index is smaller than or equal to less than or equal index, which means that the target number exists in the given array, so I return the tuple in this way. Yeah. But otherwise, the target doesn't exist in the given array, so return -1, -1 tuple. Okay, so that being said, I finished my today's coding practice. Thank you so much. Bye.